This is the two-dimensional and three-dimensional geometry review. I'm going to go over all of the solutions on your review sheet, and feel free to use a grading pen to fix anything that you missed the first time. All right, number one, Jake has a scale drawing of a floor plan of his bedroom. The scale is 50 inches to 1 inch. So we can start by setting up a proportion where we have our ratio written as a fraction, and I'm going to label this the actual over the scale amount. Okay, this is how I'm going to set up both of the proportions. So the second fraction, the actual size is what I want to find, and I'm going to start with the width, so I'll use W for that. And the scale amount is 2 1/4 of an inch, so I'm going to use 2.25 inches. Okay, then we can use cross products to solve, and we get that the width is equal to 112.5 inches. Okay, the second proportion is going to be set up the exact same way, except I'm going to substitute in L for length, and the second measurement is 2.75. Okay, then when I solve that using cross products, I'm going to get a length of 137.5 inches. Okay, part B, I just need to take those measurements and convert them into feet. So to do that, you just need to divide by 12 since there are 12 inches in 1 foot. Okay, so 112.5 divided by 12 is going to give 9.375. It does say that we can round to the nearest foot, so I'm going to round that to 9 feet. Okay, and that's the length. Then for the width, I'm going to do 137.5 divided by 12, and that's going to come out to be about 11.45, and if you want the whole amount, the 3 would end up repeating. But again, if you just take it out to the tenths place, since you're not using a calculator for this, 11.4 is all you would need, and that would let you round it to 11 feet. And then on part C, I know that there is a typo. Those should both say bedroom. You just need to find the area. So you're going to multiply 9 feet by 11 feet, and that's going to give you a total area of 99 square feet. 99 feet squared. All right, number 2, angle A measures 2x plus 40 degrees. Angle B is supplementary to angle A and measures x plus 20 degrees. A quick way to remember your complementary and supplementary, this is thanks to Katie. Thank you, Katie, for coming up with this. Supplementary starts with an S. Complementary starts with a C. What Katie showed me is that the S can turn into an 8 for 180, and the C can turn into a 9 for 90 degrees. So if that helps you remember them, then go ahead and use that. Okay, so supplementary is 180 degrees. Okay, so now when we set up our equation, we need to have our two angles, and we need to add them up and set them equal to 180 degrees. From here, we can start combining like terms. So 2x plus 1x is 3x. 40 plus 20 is 60. And that's equal to 180. So continue solving. We get 3x equals 120. And so x has to equal 40. Now it's okay if you don't put your degree sign on the 40 because this just represents what x is. We'll make sure to put our degree sign when we get down to the angles. All right, angle A is 2x plus 40. Since x is 40, we're going to do 2 times 40 plus 40. So that would be 80 plus 40 which would be 120. So angle A is 120 degrees. Angle B is x plus 20. So we're going to substitute in 40 for x and get an angle measure of 60 degrees. So angle B is 60 degrees. Now, one last thing to check. They're supposed to add up to 180. So take your two numbers, add them up, and make sure that they are supplementary. That way, if you made a simple computational mistake, you'll catch it at that step. Okay, number 3, draw a triangle with two angles that measure 35 degrees and 55 degrees, and one side that measures exactly 2 inches. I'm going to pull up my ruler and protractor for this one. Okay, there's my ruler. And there's my protractor. Okay, I would suggest starting with your 2-inch line segment. So that measures right about at 2 inches. So I'm done with the ruler part, and we can label that 2 inches. And let's move this in the middle. All right, now I'm going to use my protractor, line up the end of the segment with the center of the circle in your protractor, and we'll measure the 35 right there. Okay, so use another line segment to connect that, and make sure that you label the angle 35 degrees inside, right where the vertex is. Okay, now we're going to go to the other side, line up your protractor on the opposite endpoint, and this time we want 55 degrees. I'm going to use the other side of the protractor since I want the acute angle, and go back the other way. Ended up off just a little bit. All right, move your protractor out of the way and label this one 55 degrees. Now, it's okay if your lines overlap like that. If you are really particular, you can always erase the extra part. Either way would be fine. Okay, part 4. A picture is copied onto a sheet of paper 10 inches by 12 inches. A 2-inch margin is left all around the picture. Find the length, the width, and the area. Okay, so a lot of people weren't taking into account that it's 2 inches on all of your sides. Okay, so if the entire length is 12 inches and the entire width is 10 inches, when you take off 2 inches on each side, you need to do 12 minus 2 minus 2. So that's actually going to give you a length of 8 inches. Okay, now the width of the picture, you have to take off 2 inches from each side. So that would be 10 minus 2 minus 2, which would be 6 inches. And the area, I would do 8 inches multiplied by 6 inches, and I would get 48 inches squared. Okay, units are half of your points on this problem, so make sure that you have them. All right, number 5, this has to do with the triangle inequality theorem. So the day that we were using spaghetti and breaking it up into pieces, we came up with a theorem that said that when you take the smallest side and add it to the medium length side, it had to be greater than the largest side. If it was less than or equal, you would not get a triangle. Okay, so part A, if you have side lengths of 3, 3, and 3, you would get exactly one triangle. It would be a nice little equilateral triangle. Each angle would be 60 degrees, and there's only one way to do that. Okay, and then when you explain, say something about your triangle inequality theorem. You could prove it and say, since 3 plus 3 is greater than 6, I can use the triangle inequality theorem to prove that there's a triangle. All right, part B. If you have side lengths of 4, 6, and 10 centimeters, you are going to get your 4 and your 6 centimeter side. And those are going to be exactly the same length as your 10 centimeter side. So that will not make a triangle because they have to be greater than 10 when you add them up. So as part of your explanation, and again, you do need words, you need more than just the numbers that I'm showing, because those are equal, you don't get a triangle. So I would circle C, no triangles. All right, number 6, circle the sketch of the cross-section of a rectangular pyramid that is cut parallel to its base. Then name the shape of the cross-section. Okay, so I am looking for a rectangular pyramid. Right away, get rid of the rectangular prism. Okay, the second thing we're going to look for is the cross-section. So the first cross-section, it's the little piece inside. That's a cross-section, and that is a cross-section. Okay, the first one, that forms a 90-degree angle right here. And so that actually is called perpendicular. Okay, and that's not the one that we want. The other one, these two lines right here are parallel. Okay, so this is the one that we want. So I'm going to circle that, and then I'm going to name the cross section, and this shape right here is a rectangle. Okay, if you put square, you're being a little too specific. It doesn't tell us if it's a square, it only says rectangle. So unless we had markings, for example, maybe we had markings like this to show that it was congruent, then you could say a square. But since it doesn't, you have to go with rectangle. All right, next we have formulas for each. Area of a triangle is base times height divided by 2 using the little base. Area of a circle is pi r squared, or pi times radius. Circumference, 2 pi r, or pi times diameter. Surface area of a rectangular prism, this is our long one, 2 length times width plus 2 length times height plus 2 height times width. Surface area of any prism, this is where we find the area of each base. So we do 2 times the area of each base. And then to find the long rectangle that you get when you unfold the net, you do the perimeter of the base multiplied by the height of the prism. Okay, part F, volume of any prism is the area of the base multiplied by the height of the prism. Notice how I'm using a capital B to represent area of the base. Okay, in a cylinder, the base is a circle. So we're going to do area of the base, which is pi r squared, multiplied by height. Okay, volume of a cone, we're going to do pi r squared times height, all divided by 3. Remember, pointy things like cones and pyramids get divided by 3. Volume of a pyramid is, move it over, area of the base times height divided by 3. Okay, and our final formula, volume of a sphere, this one it's okay if you don't have memorized, but it would be 4/3 pi r cubed. All right, I'm going to pause it here so I don't go over my YouTube time, and I'll continue in the next video.